Today we're going to talk about one of the most important yet so often misunderstood parts of the modern AI stack, and that is vector stores. They allow you to extend the knowledge that your LLM, your GPT-4 call can leverage and unlock a whole host of new use cases, some of which you've heard of and a whole heap you probably haven't. Today we're going to explain them, we're going to talk about some of the use cases, and we're going to show you how you can quickly get up and running with AirOps using memory stores. Let's dive in. Vector databases are an incredibly powerful pairing for large language models because they allow you to search over large amounts of data based on semantic similarity or meaning. A real world example would be if I asked a chat app, hey, how do I reset my password? It would be able to use a vector database to pull everything we've said about password resets or things close to password resets. And this then allows us to provide those help snippets or doc snippets back to the language model to form the perfect helpful response to the user. And this is the foundation of most chat assistants out there, but can also be applied to so many other use cases. So instead of spending the next 20 minutes talking about the intricacies of how this works, let's just talk about how easy it is to get up and running with AirOps and show you some real world examples in action. Kicking off, we're going to talk about chatting to your documents, a really common use case for vector databases and one that we're going to get up and running in less than 5 minutes. So let's start with chatting to my documents, a really common use case for pairing vector databases with large language models. So the first thing I'm going to do is I'm going to create a little chat agent that I can talk to. So I'm going to head over to here inside of my AirOps workspace. I'm going to say blank agent, and it's going to create just a really simple agent here. We can see the prompt that stages the agent, tells it who to be. It says you're an AI agent that helps people find information in response to their questions and tone. And this is powered by a model called GPT 3.5 Turbo, which is a fast yet slightly less capable model than something like GPT-4. And so I'm going to hit save changes. I'm going to save a draft here and I'm going to call it my demo bot today. Let's give it a little icon. Let's just give it this for now. Hit save draft. And now when I talk to my agent, I can ask questions and it will be able to answer from its training data, but that is all. So tell me the capital of the UK. So this is basically a very simple GPT 3.5 only agent. But let's bring in our own data. And to do this, we're going to use a product called memory stores inside of AirOps. And memory stores are our simple managed vector databases. We try and keep this as simple as possible so you can get up and running quickly and get on with your day. So I head over to memory stores. I can see I've never created one before in this workspace, and I'm going to hit create memory store. I'm going to give it a name. So we're going to call this AP Biology. I'm going to hit there. And so we're going to start off and see that our memory store doesn't contain anything yet. There's no content inside of it. So let's go ahead and add something. And I can see I've got a number of different ways I can add content here, but I'm just going to pick the simplest, which is uploading a file. So I'm going to go here and I'm going to see that I have AP Biology combined notes. So this is the full AP Biology complete student notes. I'm just going to add this into my memory store and it's going to start uploading. I'm going to hit next. And now we can see that it's actually processing in the system. So this is where it's taking that PDF file and converting it into what are called embeddings that can then go into the vector database. My file is now going to take a few minutes to process, but will soon be available inside of my memory store. Great. So we can now see that my biology notes have been loaded into our memory store, into our vector database, and they're ready to go. And if I go over here and type in the test, cellular health, then it's going to go and retrieve things within the memory store that are close to that. So where is cellular health mentioned in AP Biology notes? And it's going to return snippets that we can then pass to our GPT-4 agent. So going back to Biology Bot, I'm going to jump in here. I'm going to go in over here and add the memory store we just created to this agent as a tool that it can use. And I'm going to say to GPT-4, always use this to answer questions about biology. And I'm going to hit save changes. And so now when I go test all and I say, tell me about cellular health, it's going to recognize that as a biology question. It's going to go to that tool and it's then going to use the responses from that vector database to inform the answer. And this really is the foundation of every single chat to your docs product out there. Just with AirOps, it's a lot more powerful because you can add multiple memory stores. You can add other tools as well, which you can explore over here and really just give your agent way more powers to serve your users' needs. So often you're going to want to repurpose one piece of content and turn it into something else. So in this instance, we're going to create a new new workflow within AirOps that leverages the AP Biology memory store we just created to let you create net new content for a different channel or a different audience. So the first thing I'm going to do in my workflow is specify an input, and I'm just going to say, let's give this thing a topic. So the user to run this workflow is going to need to input a topic. Keep it simple. And the next thing I'm going to do is I'm going to use the topic to pull relevant information from our memory store we just created. So I'm going to click down here and go to AP Biology. I'm going to want the first 5 results, and I'm going to use the topic that the users entered to search the memory store. So if they search for cellular health, it's going to again pull down everything that's been said in AP Biology about that. And so this is a super simple starting point, but we need another step. We need to do something with the results that are returned. And so I'm going to add an LLM step in here. And this is a way of using any number of large language models from GPT series through to Claude, through to things like Llama 2. But in this instance, I'm going to take Claude to 100K, which provides a large 100,000 token context window. So it's the largest available. And it's also a very capable model. Claude 2 is not that far behind GPT-4, and that's why we use it in a lot of different instances. So I'm now going to write a simple prompt. I'm going to say, an expert biology teacher, you are writing an informative tweet thread today based on the information I am providing below. One thing about Claude is it often likes to use pseudo sort of markup to encapsulate certain types of inputs. And so in this instance, I'm just going to wrap the output of the memory store in this just so it knows the beginning and the end. This is something that works incredibly well. We recommend doing it. And I'm going to say, please output your response in Markdown. So we've already said we're writing a tweet thread today. It's going to be based on the topic, and it's pulling information from the memory store and using it. And I'm going to ask it to stream the output there. So I'm going to save draft. I'm going to say biology tweet thread writer. And now I'm going to go over to test all, and I'm going to type in a topic. So I'm going to talk about bones and skeletons today. So first of all, it's going to search the memory store, and it's going to pull down a whole bunch of information in here where we've mentioned the words bone and skeleton before. Next, it's going to go and start writing this tweet thread. We can probably see it coming up from here. And this is really just processing the information provided and turning it into a net new content format. You could use this for processing videos. We support transcription. You could use this for turning long form content into short form. You could use it for creating emails series off of things you've already written. So a really flexible way of repurposing content and work you've already done and creating really exciting new products from that. One of the best uses of memory stores is for product or content recommendation. And so in this instance, I'm going to create a new memory store with my product information from my made up e-commerce store, and I'm going to use it to create a personalized email for a customer. So first step is I'm going to add the products to this memory store. So I've created a simple CSV. I'm then going to choose the columns that I want to make searchable. So these are the ones that will be searched when a user request is performed. So I'm going to do product description, I'm going to do product name, and I'm going to do tags, and I'm going to hit next. So this is going to now process, should take probably about 10 seconds. Now that that's ready, the products are in there. I'm now going to create a brand new workflow on AirOps. And this time I'm going to have the input to the workflow be the last product that the customer bought. So I'm going to call this last purchase. And the next step is I'm going to pull things that are close to that last purchase. So I'm going to do a memory store search step. Excuse me, let's just do that from here. So I'm going to take my products. I'm going to say I want, let's say 10. And then I'm going to add the last purchase as the search query to this memory store. I'm then going to add an LLM step, and I'm going to say, let's use GPT-4 for a little bit of extra power here. I'm going to say, you're an expert email writer. A customer has just purchased. Please can you recommend a subset of the products below in an email to the customer to help them find their next purchase. Please link each product name to the relevant product and return the answer in HTML. So obviously we haven't provided an example here, which we would normally do. And this is going to be a kind of not quite production ready example, but it will demonstrate the combination of these two technologies for use cases like this. I'm just going to put, finally, you work for a women's fashion store, Sunset Fashions, which I came up with today. So we're going to hit save there. So our workflow is basically done for the V1. Let's just put a little bag here, save, give it a name. Let's call this email writer, and let's hit test all. So the last purchase, we're going to say maxi dress here, and we're going to hit execute. So step one is fetching products from the store, and we can probably see the output appearing here. So we're thrilled that you've chosen the perfect maxi dress from Sunset Fashions. Now let's complete your look with some amazing accessories and standout pieces. So straw hat, this will add an elegant touch to your look and protect you from the sun. Leather sandals pair your maxi dress with these comfortable and stylish leather sandals for a chic summer look, and so on. So a really powerful example of pulling recommendations or semantically similar products. So I'm going to hit save my draft, email writer. Let's save that, and let's go ahead and test. I'm going to pretend my last purchase here was a very stylish maxi dress, and I'm going to hit execute, and it's going to begin to work through the workflow left to right here, and we're going to start to see the email come in. So thank you for your recent purchase from Sunset Fashions. We hope you love your new maxi dress. And then we're going to start to use the retrieved products from that memory search step, and it's going to start to recommend things that will go beautifully with my maxi dress: jewelry, sandals, a tote bag, and a scarf. So this is really trying to create a very personalized recommendation anchored in real products, and the use cases here speak for themselves, but this could be an on-site experience, a lifecycle email experience, or something that goes through to landing pages or other comms as well. Let's look at one more example. So in this instance, I'm going to turn a web page into a new article, but the web page in this case is very, very long. So the first thing I'm going to do is pass in the URL and the topic that I want to write the article about. And the next step is to use web scraping. So built into AirOps, we have a bunch of utilities that you can drop into your workflows whenever you need them. One of them is web page scraping. And so in this instance, I'm going to go and fetch the page and pull it into my workflow. But this is a really, really long page. This is maybe 50 to 100 pages of text, and I don't want to push that all into a language model prompt straight away, and I only really want a subset of it. So the first thing I'm going to do is I'm going to write to a memory store. So I'm actually going to send in this entire transcript and push it directly into the memory store, and it will be converted into embeddings there and then made usable almost instantly. The next thing I'm going to do is I'm going to take the topic. So this is what I want to write the post about, and I'm going to search the memory store for that content. As we saw before, it's going to return those little snippets that we can then use to write our piece of content. And then on the language model step here, I'm going to take the insights that I've pulled and I'm going to write a short blog post on the topic. So super basic example, but the important thing here is the framework that we're establishing. So I'm then going to go to test all. I'm going to write the topic here. And in this case, I'm going to make it overreaching versus, actually let's make it overtraining. So I'm going to write a post about overtraining, and then I'm going to hit execute, and we're going to see the logs now as this workflow runs. So we're going to pull down the page. We can see that took about 3 seconds. The next step is we're going to put that in the memory store. This will probably take a little bit longer. Okay, about 23 seconds there. We're then going to perform a search to pull down the pieces of content, and we're now going to have our model write our output. So we're just going to give it a few more seconds, and hopefully we'll have our blog post. Great. And so we can see now that the blog post has been generated, and it's referenced the pieces of content that are coming from that long form web page. So this is really a way of, inside a single workflow, pulling in a large piece of information. This could be a long video transcript, this could be a long web page or series of web pages, and then using those real time in a sort of generative flow. Super powerful. That is just a few of the use cases that are made possible when you combine vector databases with large language models through AirOps. We are really excited to see what you come up with and encourage you to come and try AirOps for free, create an account, start uploading some documents and data, and see how far you can push it. People are just beginning to understand what's possible with large language models, let alone what happens when you add vector databases to the mix. Sign up today, join our Slack community where our team is helping people like you all day long get up and running, and I'm really excited to see what you build with this. If you like this video, you found it helpful, please like and subscribe, and we'll see you at the next one. Thanks.